Welcome back to your next lesson, Recruit. Now it's time to discuss Python lists. Lists are ordered sequences that can hold a variety of object types. They use the same square bracket notation that we've seen earlier and commas to separate out objects in a list. Here we can see an example of a list of integers. Lists support indexing and slicing, and lists can be nested and also have a variety of useful methods that can be called off of them. Let's explore all these concepts by opening a Jupyter Notebook. Let's start off by making an example list. We'll say my list and create an example list of integers. Something you want to avoid doing, as we've mentioned in the past when choosing variable names, is if you choose the variable name list, you notice that it's actually highlighted. That means it's a pre-built-in keyword and you don't want to use that. If you've accidentally already did some sort of assignment like list is 1, 2, 3, what you should do is go to kernel and then hit restart. Then make sure you delete or comment out that line. Continuing on, notice that we have my list. Now here I have a list of integers, but I can also create a list of strings, such as A, another string, triple B, another string, just a bunch of random letters or characters, and then we see my list is there as well. And also note that we can have mixed data types, so I can have integers, floats, and then strings as well, all mixed up here, and the list has no problem with that. Now let's discuss quickly indexing and slicing. It basically works the exact same way as in a string. We'll create a brand new list and we'll have this be a list of letters. We'll say A, B, C, and D. And then if I check out my list, I have the list of letters. Imagine I wanted to grab the first item in my list. That's the string A. So I can say my list 0 and then that's A. If I want to grab A, B, and C, well, let's think about this. I want to grab 0, 1, 2, and then up to, but not including 3, which means I start at 0, and then go up to and don't include 3, and then I have a list. So notice here, it returns back the list subsection. Now I want to quickly make a note here that Python has built-in functions. We just saw that list was actually pre-built into Python as a essentially a special keyword that we're going to use later on. You can use it to transform things into lists. There's a really useful built-in function called len for length, and this allows you to return back the length of objects. So if you pass in a string into this, so hello, it's going to return back how many characters are in that string. And likewise, if you pass in a list to this, say my list, it's going to return back how many objects are in that list. So you should also be careful of not wanting to overwrite len with some other functionality or some other variable. Now let's go ahead and move on to discuss useful list methods. We just saw that strings had methods such as upper and lower and split, and we saw that split created that list, and we've learned a little bit more about lists so far. I want to discuss methods that can be called off of a list object. To do this, we'll say my list is equal to 1, 2, 3. And one really useful method is appending to a list. And appending to a list allows us to add something on to the end of a list. We can say my list dot append, and you should be able to tab autocomplete this. If you're not able to tab autocomplete it, it's probably because you actually haven't ran the cell that defined my list yet. And then append just allows you to append another item to the end of a list. So right now my list is 1, 2, 3. Let's go ahead and append 4 to it. And then I can check that my list is now 1, 2, 3, 4. If I want to remove an item from the end of my list, I can use the pop method. I will say pop, make sure to do open close parentheses. If you don't, again, you just get the report back of what it is. Open close parentheses, run that, and notice it returns back the last item of my list, which happened to be 4. And this is an in-place method, meaning it actually affects the current variable in place. So if I take a look at my list again, it no longer has that 4. Okay, let's go ahead and append 4 again one more time. We'll say my list, append 4, and then we see my list. Imagine that I wanted to remove not the last item of my list, but the first item of my list. How can I do that? Well, pop takes in parameters, and later on we'll see that many methods actually take in parameters in order to adjust what the method's going to do. we'll say mylist.pop, and I can do Shift-Tab to see the documentation string of this method. And it says back l.pop, and it's going to remove and return the item at the index, meaning that I can actually provide an index location to this pop argument. So by default, the index is -1, meaning it returns back the very last item of the list. But if you want to grab the first item, you could say 0 for index 0, and it pops off the first item of that list. So now that I see my list, I see 2, 3, 4, and I remove that first item. Let's do mylist is equal to 1, 2, 3, 4 one more time here to show my list again. Notice that my list pop is actually returning back this either first item, second item, or whatever you happen to put for the index. If I actually wanted to save that item as a variable, what I can do is say my first item is equal to, let's put in some underscores for snake casing here. My first item is equal to mylist.pop 0. So what is happening here is we're popping off the first element in that list, and we're actually saving it to my first item. So my list no longer has that number 1. Instead, we've been able to save it as my first item. This general idea of methods returning things or operating in place is sometimes a little confusing for new recruits, and it takes a little while to build some sort of intuition about what's going on with a method. And I want to show you a couple more examples to get an idea of methods that sometimes don't return anything or operate in place. So let's go ahead and say my list again is equal to, we're going to say 1, 2, 3, 4, 5. Okay, I have my list, and if I do dot and then hit tab, I notice there's a lot of methods here. I'm going to use the reverse method now. So this method, interestingly enough, doesn't actually return anything. Instead, it operates in place. So if I take a look at my list now, it's been reversed. What I cannot do is something like this. Result is equal to my list reverse. Because my list.reverse is occurring in place, it means it's affecting the actual variable my list, and it's not actually returning anything. So if I take a look at results, I don't get anything back. It basically does not return anything. And this idea of returning something is going to come into play when we learn how to build out our own functions. So keep that idea of returning something or not returning something in the back of your mind. For when we cover functions, we're actually going to use a return keyword. But for now, just keep a general idea that some functions or some methods won't return anything and others will affect the variable in place. Another very similar method to reverse is sorting. So if I say my list is equal to, and let's put in a bunch of kind of random unsorted numbers here, I can actually say my list dot and then say sort, and nothing's returned here, meaning my list has been sorted in place. So the methods we've gone over so far is sorting a list, reversing a list, popping an item off of a list, and this is something where we do return an object, and then we have appending to a list. Nothing's returned here, we just add on an object to the very end. Now if we want to not put in an object at the very end, but actually insert it to a special location, we can use the .insert method for that. So we'll create one last list here for our example, 1, 2, 3, and instead of appending to the very end, I want to insert it as the first item, that is index 0. Then I can say insert, and the first argument is the index position of where you want to insert this. I will insert this at 0, that is the first item, and then let's make it really obvious by saying new, and then now if I check my list, I see new 1, 2, 3. Okay, so you have insert with the capability of inserting this item at any location. Finally, the last topic I want to cover is nested lists, and that's just the idea that a list can hold not just the variable objects that we've seen before, like floats, numbers, or strings, it can actually hold in other lists. So I can say, let's get a couple empty cells here, a new list equal to 1, 2, comma, and then I can insert another sublist here, B, C. So now notice that I have a list inside of another list. And the type of this is still a list. So imagine I wanted to grab the letter A from this list. How would I actually do that? Well, I would need to check out my list and index out this nested list. So that is at 0, 1, index 2. So let's grab that. And now I've been able to retrieve that list itself. And then actually off of this, I can perform another set of index calls to grab the first item here, which is A at index 0. And then I can grab the string A. Having more than one level of a nested list is not really that common. It's sometimes pretty common to see objects nested one level in, such as a list inside of another list. It's pretty uncommon to see a list inside of a list inside of a list, etc., just because it gets so hard and tricky to retrieve things. Okay, that's it for this lesson. We'll see you at the next one.